Good morning, everybody. Thanks for joining us. And I'm just going to intro what we're going to do today, and then we'll get into some talks, and then we will move into breakout groups to do some hacking, unconferencing, community development, whichever one you want to call it. There's a attendee list, and we'll be taking notes, and you are welcome to contribute to taking notes because I can't do it all at that tiny URL. It's just a Google Doc. So I'm a co-chair of the ESIP drone cluster, which is probably the hat I'm wearing while I'm here. I'm also a researcher at the University of Notre Dame, along with my co-PI for this project, Chuck Bodeman, computational science professor. And this is, I'm the PI, and Chuck and I are working together from Notre Dame on this, but this is really the culmination of the ESIP drone cluster's last 3+ years of discussing with the community here about how we could support drone data and what is needed. And this is our first attempt to use some money to actually build things. So Lander's linked data API for network drones, in essence, we want to make an API and we want to allow it or build it such that we can support linked data for drone data. Our foremost target is earth science. Drones are changing how many, you would call small scientists are capturing data and enabling them to capture data at a far greater resolution and rate, temporal resolution than was otherwise possible, but there isn't currently really much infrastructure to support them in terms of moving towards making that data standardized, sharing it, publishing it, getting credit for it, and similar. So this is the combination of that. Today I'll talk a little bit more about the what, why, and how of Landers. I'll introduce today and then talk a little bit about how you can get involved. This is just a diagram that some of you have probably already seen, but the drone data pipeline is actually really complicated, especially if you want to anybody else to ever reuse your data. This is one of the outputs from previous ESIP drone work, just categorizing all the different steps that are involved in a drone flight. And at every one of those stages, there is metadata that needs to be captured if somebody else is going to be able to really reuse your data. A fantastic example is, if anybody here is part of the atmospheric science community, ISARA has a regular annual flight week. And this last one they did last year, everybody flew various atmospheric sensors, primarily pressure, temperature, humidity. I don't think they had any gas fluxes, but whatever. And then they tried to compare. They all flew against the tower, and then they tried to compare those data. And it was incredibly difficult, to the point of being impossible, because you need to know, where was that sensor mounted? When was it last calibrated? What sensor is it? How were you sampling at 1 Hertz, 2 Hertz, 10 Hertz, et cetera, et cetera. So there are many things that need to be captured, and we're trying to build tools to help that, or rather build an API that would allow you to build tools to help with that. So yeah, the goal is to do this all in community. I also co-chair the drone data group, the SUAS data group for RDA. We started that, myself and my co-chair, Lindsay Barberi, who is in here today, because we realized we were doing some stuff that there seemed to be a need for, but ESIP is obviously primarily North American, and so trying to reach Europe's doing some great stuff with drones as well, particularly Africa, Australia. We wanted to reach out to the broader community, and so yeah, the point of doing this is to do it as a community effort. Don't want to reinvent the wheel. A lot of different groups are building small things, well, serving their own needs as they need to. They need to deliver on funding. So we want to work with them, and then there's obviously industry is playing a big role in the drone world. There are holes, which is where we think we come in, but we would like to work with them as well. And the primary outputs of this project are going to be some APIs. The foci of those APIs are supporting semantics, supporting schema, and supporting transport and capture data provenance. And then, so along with the API effort, which is code hacking, along with a lot of communication within the community, is RDA has a mechanism where you spin off a a working group, which is an 18-month effort to deliver an output that serves a need. It's a little bit more formally controlled than ESIP, also community organization, but they provide technical review and auditing and basically facilitate you not to generate a standard, but to generate best practices or other outputs. And so we want to use that pipeline to try and fill some of the other holes that are in the drone data management ecosystem. If any of you have been on the mailing list for any extended period of time, you'll have seen a lot of emails about a paper we put together, and this is the primary output from that paper. It's 8 challenges or 8 needs in the drone data community. This project isn't looking at all of them, it's looking at those 4. And it's not even going to solve all those 4 entirely, but to give you a sense, and the references in the slides, if you or go and look at the mailing list archives, you'll find its paper's been approved. I just need to say yes, it's fine, and it will get published. Final camera ready. I really liked, I don't remember his name, I'm afraid, the middle speaker this morning, who talked about how fair is becoming a dirty word just from overuse, but I assume everybody here agrees that fair is important to some measure. And so we're going into this process with the goal of, okay, so the point is to A, enable data science, but part of that is pushing towards fair, at least. And the reason we can't just use off-the-shelf components that are already there, or anything from manned aircraft, or the other domains that have been doing sensing in their domains for years, is that drone data is slightly different. Again, I point you to that paper that discusses what we've been discussing for the last 4 years in detail about why we think we can't just cut and paste from existing practices and tools. But in summary, the dimensionality of drone data is unique. The spatial and temporal resolution is obviously unique. They're classically big. It's not just a temperature sense on the ground. A single flight can easily generate multiple terabytes. And then this thing about they're increasingly being used by so-called small science, which isn't supported by a large NASA scale infrastructure to help you with your data management. Why semantically rich and linked data? Again, I think this morning actually probably said it better than I can, but because in essence, we're moving to that world. And the only way we're going to be able to share and interoperate our data with each other is if we package that data with semantics, so that Tom on the other side of the planet, when he looks at your oceanography data from a drone, understands, well, this is what you meant. And equally, even oceanographer on the other side of the planet might have a different definition, but what about an oceanographer to an agricultural scientist? The terms and how they use those terms is likely to differ slightly, and we need to allow people to fully understand what that means. That's on the human level. Machines, as everything gets smartified, we want drones to be able to interoperate with all the machinery and smart that is happening around us, whether that's your data analytics engine, your data sharing portal, or your city's drone airspace control system. So making it linked data and making it semantically rich enables machine interoperability or machine readability. And then, yeah, no, primarily about interoperability, but everything else in FAIR is applicable here too. Project timeline, we're in the beginning phases. Today is our first workshop. In October, we'll have our second design workshop. So we're in a 6 months of design phase. We're gonna have a year of implementation and then another 6 months of deployment. And the deployment stage is when we are looking for a domain or a institution to come to us and say, I want to implement tools for agricultural science, or I want to implement tools for atmospheric science using the API that we've just spent a year developing. And alongside those workshops, there's funding for student exchanges effectively. So atmospheric science, computational scientist, semantics, there are places for those people to come and work. So if you have students who want to come and work with us for a chunk of time, get in touch. So today, kickoff day, like I said, two stages. This morning we're going to have some talks just to get us all on the common base level. There are talks about current drone data tooling. And then this afternoon is going to be an unconference or a VO camp or an unstructured period of time where we're going to break up into groups, and you're going to go and work on developing whatever but you find interesting or you feel like you have the skills to. So final part of this morning, just before we break for brunch, is we, through the mailing list and through discussions of the last few months, have pulled out what we think are topics that we should address and look to here. And a couple of us are going to pitch what we think. If you have another idea, if you come to the end of this morning and say, this is really important, I think we have the right people here to work on this, you're welcome to say so. The afternoon is very much a vote with your feet. There might be topics that nobody here in this room is interested in, and that's fine. Yeah, these slides will get posted. There's a Slack channel, there's a GitHub repo, there's 2 mailing lists. I would suggest joining the Slack channel as the most reliable source of information, but if you're on the ESA mailing list or if you're not in RDA mailing list, a lot of stuff will get posted to both. So, Joe, if you'd like to come and show us USGS's drone data stack. F5?
Yeah, I think you have to find the little icon.
Welcome to VoiceOver.
Oh. No idea. View. There we go.
I'm going to try to turn this off to get rid of our screen issue. See if this works. Yeah, that fits better. Okay. Hi, everybody. So I think I'm seeing quite a few familiar faces. So you may have seen these, a lot of this information before. I'm going to go through this pretty quick. It's just to talk about what we currently do at our office. So I work at the National UAS Project Office in Denver, Colorado. We're there to support drones in USGS. We've been doing it 10 plus years because we've kind of been around the longest. We get asked by all agencies in Department of Interior for help. And so you're going to see, my perspective is that I help a lot of different scientists. You're going to see what we kind of do most of the time, but USGS is a lot of centers and projects doing their own thing. So there are going to be a lot of things going on out there in USGS that I'm not going to cover. There is, USGS is very open and independent at all these centers, so projects do their own thing. We're trying to dictate, we don't dictate hardly anything that happens. We train people to use drones. Our week of training is how to safely operate drones in Department of Interior and reporting and procedures, but that week of training we do not teach them how to collect data or how to manage data. And so it is kind of the Wild West, and I keep hoping our scientists out there will grab the reins and drive this thing a little better. But we're all here because no one has time to do this or be funded to do it well. And so we are flying these drones right now. We're getting going with the DJI Matrice 600 and Mavic Pro. We've been flying 3D robotic solos for 3-4 years now. We've got the paired Nanafi going. We've got the vertical takeoff and landing bird's eye view Firefly. The one Vapor 55 we had went in the Colorado River, and it is in pieces in our office, about to be surplused right now. We're flying all kinds of different sensors, cameras. The mainstay that we collect most of our data with is the Ricoh GR2, great little camera for photogrammetry. We're doing multispectral and some thermal. We've got the Doppler radar here on the bottom is for surface water velocity of rivers. In Hawaii during volcanoes, we started flying gas sensors for the Hawaii Volcano Observatory guys, sniffing what was coming out of the Kilauea crater and over the lava flows down in the lower East Rift zone. We started flying a ground penetrating radar. That's back to the water guys to be able to fly a transect across a river, get the bathymetry with this ground penetrating radar and the water velocity and calculate discharge. Water guys are leaders in USGS in using drones. We fly, at the moment in my office, we have a yellow scan surveyor LiDAR we're flying on a Matrice 600 now. We've got a phase 1 camera we haven't made run yet. We have that Rosanin hyperspectral. We flew a headwall nano hyperspectral sensor that was on the Pulse Vapor 55 when it went in the Colorado River, and so that's not flying at the moment. And we did some telemetry with NASA and tracking tags on Asian carp. So Jane already presented this. It's pretty much the same for everybody. Plan, go out and collect, process it, and then in USGS we have a fairly defined publishing process that we have to go through. So I'm going to run through each of these really quick and just quickly talk about all this stuff we're doing by hand right now. So we plan, often it's in Google Earth. Just think about the areas, the ownership, the wildlife refuges, where we can and can't go, who are we going to piss off or not piss off if we fly a drone. Global Mapper is my go-to GIS tool right now, light and fast and helping us pull in information and plan. Global Mapper has a built-in aviation sectional chart layer. We start to look at airspace, know that we're good to fly. SkyVector website is our go-to for looking at sectional charts, and that's our big thing with drones, knowing what all these lines and everything means to be able to know if we're allowed to fly in an area or not by the FAA. And AirMap is another great tool to know if you can fly in a spot or not. You just go to a map and you click, and AirMap will give you little warnings about the area that you want to fly. And then when we actually get ready to go collect data, the ArduPilot Pixhawk community has Mission Planner, Windows-based tool, and we use Mission Planner most of the time to figure out where the drone has to fly to take pictures or collect data with a sensor with the proper overlap so we cover the area properly. So this tool in Mission Planner is called the Auto Waypoint Generation Tool, Grid Tool. On the right-hand side, upper right, this work? Up here, you select the camera, and that camera has a lens and a sensor size, and that determines how high you fly, what the footprint of an image is going to be on the ground. And then down here on the bottom, we get all kinds of great stats that what I'm looking at most of the time. If I pick a flight speed, how fast the camera has to trigger photos every so many seconds to get a proper overlap. And so this tool on the different tabs is where we can pick overlap. I do 70% most of the time for the Rico. And if you need to fly a new camera that you haven't configured before, you can find the parameters and type in sensor size, image size, focal length to help determine these things. Once we're done with planning, we're heading out to the field. We generate this waypoint file with the transects. That translates over to a tower app. So those same waypoints that I made in Mission Planner, we transfer over to tower on a tablet or a phone. And for our 3D robotic solo, that's what we fly the drone with, to upload the waypoints and tell it go. And it autonomously goes and flies the waypoints. So there's, like Jane mentioned, there's all this information being generated throughout the entire process that we would like to capture. And so I would like to be able to make sure somebody in the future knows that I flew this and why I made these decisions. So if we could capture it somehow along the way and be able to make it part of a package we publish, that's our ultimate goal. We're flying the DJI products now, and so we have a special version of the DJI Pilot app that's called Private Edition. And so in this particular setup, so you're looking at building 810 on the Denver Federal Center. I was flying the solar panels for GSA to help them know if hail smashed and broke some of their solar panels. And so this was planning a Mavic Pro to record video back and forth flying along their solar panels for them. And behind the scenes, there's all kinds of great data behind this app. I'd love to be able to capture, package up, and either parse to put into metadata, well, both parse and provide those files along with the data. We're also using Pix4D capture with the Parrot and Offie. And then when we're out in the field, we're doing a lot with just the computer and Windows Explorer, looking at files. Is this data good? Do my pictures look okay? Are they crap? Do I need to refly? WinSCP's on there because the 3D robotics solos have a little onboard computer you can connect to with SSH and go and download log files. There's a great log file in the Pixhawk flight computer called a data flash log that has all kinds of great info. Sometimes we're running Agisoft PhotoScan, checking our overlap and things. I've got locus maps and Avenza on here because that's what I use when I'm putting down ground control points, where I need to go walk to put a ground control point. Then we get back to the office and we process. EXIF tool is a wonderful little tool for dealing with imagery. And I just love it because you can make a desktop icon, drag an image over to it, and dump out all of the metadata. And last week I was flying for the first time a Centera double 4K camera, and I could not find anywhere in the documentation what were the bands, the spectral bands for the camera. I used EXIF tool, dumped the EXIF data, and sure enough, central, the band name, central wavelength, and the width right there, red on the first 8 bits, garbage on the next 8 bits, and NIR on the third 8 bits in there. And we got 625 nanometers and 850 nanometers. It's all in there in the EXIF. We also use EXIF tool. The Ricoh GR camera we use has this bad habit, even though you have a setting called auto rotate and we turn it off, we still get pictures back switching between portrait and landscape. So I use EXIF tool to strip off the orientation tag on all the JPEGs, so that problem goes away. Flying the FLIR View Pro R camera on the 3DR Solo. Sometimes the GPS geotags the photos, sometimes it doesn't. When it doesn't, there's GPS information in the photos, but it's all zeros. That really pisses a lot of things off. So use EXIF tool to strip out the GPS tags when they're bad. And then GeoSetter is my primary go-to tool for geotagging the Ricoh imagery from GPS logs based on timestamps, lining things up. And then after photo images are geotagged, we pull them into, it used to be PhotoScan, now it's Metashape, and we align those photos with our structure for motion process. And end result is some sort of ortho usually, or DEM, or point cloud, or all of the above. We also, when we fly LiDAR, we're using a Planix pause pack, maybe it's called Trimble now, I'm not sure which, to process LiDAR. And we use Global Mapper and Cloud Compare for combining point clouds and classifying points. And then the sexy stuff, usually in presentations, comes out of Camtasia, grabbing screenshots of 3D models, rotating and things like that. And then once a scientist has made all of this stuff to actually let it out into the wild from USGS, we have our publishing process. Before they can let stuff out, they need to have metadata. The go-to tool for metadata, everybody has their favorite tool. I direct people to the Metadata Wizard 2.0, developed by our Fort Collins Science Center. Most people seem to like this. Seems to be intuitive. Once they have their metadata packaged up together in USGS, we have the Information Product Data System, IPDS. Most scientists will grumble when they hear that word, but that is the workflow process for submitting something to be published, getting it reviewed, reviewers signing off, and it actually be blessed to be released. Once something's blessed to be released, we have to find a trusted repository to store this data. We've got two places, obvious places right now. Ryan Longhenry's back here on the left in the room, and he's in charge of Aros's USGS long-term archive. He holds data for all kinds of stuff, Landsat plus 300 plus other things. Ryan can hold a whole bunch of data. And he puts a face on that data with earthexplorer.usgs.gov. And so Ryan has created for us a UAS category in Earth Explorer. Ryan's ready to hold the raw data immediately, and we have a little bit of debate where the raw data should just go to Ryan right away without an official publishing process. If no interpretation is done, no products are made, just give the raw data to Ryan right away. Ryan can also hold the products we make, DEMS, orthos, and point clouds. So you can search through that data, get footprints to come up. And then we have Sciencebase. There's another group in USGS that's made a place for scientists to be able to put a face on their data releases, on their data. Let's see if this will work. And so scientists can publish, providing metadata and titles and descriptions of their data. And this is from our Woods Hole Science Center, publishing some data they did. So Sciencebase provides parent and child pages. So you're seeing the top level page for this data release. And we scroll down here. And you can see the child, they broke out the ground control points, the multispectral data, and the RGB data into 3 different child pages. So I'm going to click on the True Color RGB data. That takes us over to this page where they describe the RGB data. You give you a thumbnail of the flight lines, the transects they flew. And then down here, you can get some sample images. You can get some metadata about this. And then just recently, Ryan provided a link over to Earth Explorer with a search query to go get their data in Earth Explorer. So if we click on that, that pops over to Earth Explorer. And Ryan's going to be working on his system on Wednesday, it looks like. And it gives you an initial search or initial listing into the records over in Earth Explorer. And so we're going to keep working with Ryan on this to make this better and better. Right now, his return is limited to 1,000 records, even though we may have several thousand images on a product. So we're going to work on improving this. But Ryan has got the space to hold everything. Sciencebase can't really hold all of our UAS data, the terabytes that we produce. They have a nice front end, so we're going to try to work together to make those two work. And let's come back to here. And I wanted to talk about one thing. So we're moving forward with offices doing publishing, but I'm not overly proud of what we're putting out. And that's why I don't really publish anything, is because I'm not yet comfortable with how to talk about this and making sure it's accurate. So I brought up this example. Sam Caldwell published this data set, and we were on the phone on a little team conference call with the Northeast region. and he talked about publishing, and I was reading through his paragraph, and I'm like, so Sam, your overlap, 70% front lap and 30% side lap. It's like, man, Sam, I've never heard of 30% side lap. And then realized that, well, Sam didn't really fly this data, somebody else did, and Sam didn't tell him they published that data, and no, it wasn't 30%, it was something else. And so we've got a ways to go before this is going to be clean and confident, but we're trying to move forward. We're trying to move forward. And go. The demo worked. And so stuff gets published. So behind Ryan's Earth Explorer and down in Sciencebase, metadata is harvested and pushed up into the USGS Science Data Catalog. The Science Data Catalog from USGS filters up to DOI. DOI's data catalog filters up to data.gov. So the metadata is getting indexed in data.gov and is searchable at data.gov. We all know we got a long ways to go to make that really good semantics ontology so that all of that works well. So another big pain point in DOI is separate from the data is just our Office of Aviation Services is responsible for anything that leaves the ground in Department of Interior. We are supposed to log and track our aircraft time and pilot time. They're capturing it right now with a Google form. This is a major pain in the ass, so we're probably under-reporting by 25%, I'm guessing. I hardly ever do this because I just don't have the frickin' time. We were in Hawaii, started April 17th flying the lava flows and volcanoes. The boss is Brad Kokeritz, head of drones in Department of Interior. He was there with us on a 5-man team. We sat down one night in our room to start doing 2U entries of our flights. And Brad grabbed a couple of sheets and sat down with this form, and he was there about 5 minutes. He threw up his arms and said, "This is crap," and closed his laptop and gave up. So he knows it's bad. We're hoping to replace this, I've heard, with Microsoft Power BI toolbox to try to build something better. I know, but you know, those high-level managers, they get sold really easy by IBM and Microsoft on stuff. Where I'm going with this is that, so all of that, we have Google Sheets right now where all of our flight data is, and it's when you see a report that recently came out about UAS activity in 2018 and 10,000 flights in 2018, it comes from this data. I'm here, and my vision is for what I'm calling Data Buddy. I want a tool that's running on a laptop that's taking care of all of this crap, all of this little crap, all of these clicks, all of these tools I showed you. I'm calling it Data Buddy. That's why I'm here, is to help create a framework that I can make Data Buddy, give to our guys, and life and data gets better. And we've got our team at the office. Any questions? Okay, next. Oh yeah, I see a hand. Shoot.
So with Data Buddy is you started off the presentation. You started off the presentation mentioning how you have a 1-week short course on the drones, and that covers, I guess, the part. I forget what part it is. But
107.
The part 107. Thank you. And it's tough that they should be able to pass that exam, and it has nothing about how to actually handle the data.
Correct.
Do you see, as part of the development of Joe's Data Buddy, Joe's vision of Data Buddy, being able to work with the community here to have small micro courses of 20 minutes that could be injected into the Part 107 course, that basically they could take a coffee break and learn a little bit about the data process and then get back to the Part 107.
Yes.
And do that maybe once a day.
Yeah, yes. So as we speak, we have bought, so the head of training in Department of Interior is Colin Malone. I don't know exactly, but I think he got some sort of degree in videography, and he's all about getting our training online and making little training nuggets to try to reduce classroom time and make more flying time. So yes, I spend way too much time repeating myself over and over again, teaching people over the phone how to geotag. Yes, we want to get there. Okay. All right, guys.
Thank you very much.
Uh-huh.
See if I can get going.
Do you know where you put it?
Yes, I do.
Great. I don't know your bio, so I'm gonna let you introduce yourself.
Yes. Okay, let's see. Not familiar with PowerPoint, so I might need some assistance here. Here we go. All right. What was it, Joe? What was the trick that you did?
What
was the trick to make it fit?
I turned off presentation mode.
Oh, I need presentation mode.
Upper, it's like right there. That one.
This one?
Yep.
Okay, pro tip. Awesome. Good thing I brought my laptop so I can read my notes.
Thanks to everybody who's been helping take notes.
Just give me a second to finish getting set up. All right. Hello, everyone. I am Christian Alfer, and I am at the University of Arizona, scientific programmer and data scientist. And so I'm here to talk about the drone data, Sciverse, and how it applies to the agricultural sciences. So this is my schedule of what I'm planning on covering today. I'm going to introduce myself in greater detail, talk about agricultural science in brief. I believe that we face a lot of the same things, but there are some unique aspects to this. Talk about Sciverse and the drone pipeline at the University of Arizona and just areas of concern that we have around using drones for the plant scientists. I think their space is a little bit unique. Oops, sorry. Okay, so my background. I graduated with computer science, and I've been programmer, director. I've been in the public sector private sector, non-university sector for my whole career. It's my, I have for the past 15 years worked with EagleView. Here's an example of an image that we have taken. So this is flying small planes with high resolution imagery. And I worked on the delivery and processing of the aerial imagery and a lot of the pipelines surrounding the capture and delivery of those systems. So agricultural science. Basically, it all revolves around field trials. So it means that you've done something to your plants and now you want to see how the plants react in different environments. To get more information, genomes2fields.org is a good place to get an idea as to what plant scientists do. Going from left to right here, going from left to right. This is really getting confusing. I have two things to click. So my apologies on that. On the left, you have greenhouses. So those are really good for checking whether your plants express any sort of traits. Very controlled environment, lots and lots of details. And greenhouses, you think about a greenhouse, but these can be acres and acres in size. So they can go from very small attachments or rooms to just gigantic structures. In the middle, we have small field trials. This is a more traditional field trial. What you get from these is that you are putting your plant out in the real world. So once you express a trait, it could have negative impact in the real world. So you get the desired aspect of the plant, but then you put it out there and you find that it's extra sensitive to direct sunlight, or it needs a lot more water than expected. These are still good because you can also, they're manageable size. You can get a lot of detailed information on the plants, and you minimize the environmental stressors for the microclimate. So you can get a more unified idea of what is going on with the plants, or more control, I should say. And then you have the continental scale. This is not one field across the continent, but it's a bunch of fields in different sites. And this is where you proof your the plant. So you have a variety of microclimates, macroclimates, and you can determine that you are actually getting the results that you want. There's a lot of drawbacks to these. Each of these things, greenhouses, I mentioned a few, they may be too controlled. The environment may be too controlled. The small fields, you can get unexpected events that just wipe out your entire crop. A sandstorm, too much rain, too little rain, insect infestation. Continental scales, while you can proof your plant, you also have the problem in that it's hard to measure. You have so many plants over such a big area that you can't really get the details of if something goes wrong. For example, your crops are off by 2% in your yield, what exactly went wrong? So with any science, you need to measure what you have. So there's different ways of measuring. One is to measure by hand. You actually go out with a tool and you measure each and every plant, and you get a lot of nice detailed results. You can measure exactly what you want. In the middle, you can see that you can bring plants to machines. That is uprooting a plant, bringing it to machine, growing a machine in a pot. Growing a plant in a pot and bringing it to the machine. Lots of high accuracy, but if it's taking a plant from a field, it's a one-shot deal, and it may not be indicative of what you're looking for overall. You can also bring your machines to the plant. On the upper right, we have the TerraRef project, which I'll be referencing throughout. It's in a field site in Maricopa. This is a large-scale movable gantry. The box in the middle has lots of different sensors. It's got LiDAR, RGB cameras, and some other sensors, and it can produce up to 200 terabytes of data in one go. Bottom right is actually really new to agriculture, even though not to the world. And I'll get into a little bit more about what those are, but this is about the issues around drone flights. But it's very exciting because it's very lightweight and you can get a lot of good information from it. This is our field site in Maricopa, and it's a sample field site. It's the largest movable gantry in the world. Thank you for pointing that out. And this is a project that came from ARPA-E, and we are building off of this drone pipeline. Building off the TerraRef project for processing the drone pipeline. So while other people talk about the capture aspect and planning aspect, we're focusing on the processing aspect of what drones can capture. I mentioned before we have 200 gigabytes per data run, so this is a lot of data that can be processed from a variety of sensors. And a crucial aspect of this project is that it integrates with Pecan for further processing of the data that is captured. So to assist the data scientists or the plant scientists, we're building this flexible pipeline. And the concept is that, so right now when scientists want to use drones, they're building up their entire processing pipeline to get to the point where they can apply their domain-specific knowledge to the information that they've gathered. We're trying to lower that bar of entry for them through an open source software project. Let me see. So BCAN is an important aspect of that. It is a parameterization and calibration of crop models. So you are able to then not only collect your RGB, but you can integrate it with your weather data. You can, I'm not sure of all the aspects because I'm not a plant scientist, but it allows you to use different conditions and to do predictive modeling on the data that you have based upon where you are at the moment. So it's a pretty cool aspect of it. And so we're using that as an interface for the, or as an aspect of the entire processing environment. Some of the things that we want to make it easy for them to do is to customize, for scientists, is to customize their workflow, insert their own algorithms into a workflow so that they easily, right now there's a little bit of a barrier of entry there, and to make meaningful algorithms. Thank you. Making meaningful algorithms publicly available. So if a scientist comes up with a new way of isolating a plant from the field to allow greater analysis, we want to make that easily available to other plant scientists. And so that's part of our directive. And also, a key aspect is reproducibility. So we want to be able to have anybody take that same data set, recreate the environment that produced the results, and to simplify. Boy, I just can't talk this morning. And to simplify, so we want to simplify the whole process of them taking their data, applying the processing to get the same results so that they can validate their results. So all that data, as we know in capturing drones, we need to give it a home, and Sciencebase is what we're using to provide that home. So on this slide is the Sciencebase ecosystem. They have a lot of different things that they provide. What we are using are mostly on the bottom part here. So we're using their cloud systems at this point, their database capabilities and storages, and also going in the near future, we're going to leverage our high performance computing. We're also using the OpenStack environment for managing the systems that we have for the drone processing pipeline. The purpose of the mission of Sciencebase is to deploy, design, and expand the national cyber infrastructure for life science research and to train scientists in their use. So this ties in a lot with what we wanted to do in teaching or providing outreach for plant scientists that are new to the drone environment, how to set up and use their drones to capture the information that they're interested in the field. They also provide IT expertise, so they are our IT go-to. They're a very friendly bunch of people, and we've had great experience with the Sciencebase folks in providing the stuff that we need for standing up our hardware and our processing environments. So I'm going to get into a little bit about the processing of the drone pipeline that we're building. So so basically we just capture the raw data, and then after that you feed it into this system, the Clouder system. Clouder is a it's a NSF. I believe it's an NSF funded project. It is also used by the TerraRef project. Excuse me. The items that you see in blue are the different aspects of Clouder. So we have RabbitMQ, which is used for the messaging messaging between the different components. We have MongoDB for data storage. It can store a lot of different information, drone data, metadata, you name it, it stores the data. You may be already familiar with this. We use Elasticsearch for the search. We have GeoStreams, which is a relational database as part of that. What you do is you develop these different extractors, you load your data into Clouder, and then you start the processing, right? And so there's some inherited workflow in that, and so some of the work that we're doing is to customize that. And I see I'm going over time, so once you have the extractions runs, BettyDB is a relational database for the traits. And then iRods is a file server that allows you to access the processed metadata. So we have some areas of concern around the drone captures. From a scientific point of view, the quality of the image of the data that you're capturing, it just varies a lot around with the drone. So plant scientists new to the field, they want to capture something, they don't know what drone to use. It can be, usually it's dictated by budget or who they can borrow a drone from. So one of the things that would be nice, it would be that there's some sort of known mechanism for with the drone to ascertain whether they will be able to use that drone for what they're trying to capture. The scientific metadata isn't automatically available when they run these flights. So this is such information as their field names or their plot outlines. This isn't, I mean, we've talked about this, I've heard it around, and this isn't anything that's new. It's just another barrier of entry for the scientists to use that want to use drones for their data, for capturing their data. Storage, curation, and archiving of large amounts of data, that's common again. And I think, procedures and policies are will assist with that. Complete coverage of an area isn't given. So this was Joe ahead of me talked about that. It takes a lot of knowledge to learn how to use these tools to do the proper flight planning. And you may not even know that you need to do flight planning. You might be just out there scientist might be out there with a joystick. So that's a large barrier of entry from the plant scientist perspective to say, well, sure, I could fly a drone, but I don't know whether I've captured everything. And then you have this is a data quality aspect. You don't necessarily do, even if you fly the same flight path, you may not capture the same information each time due to atmospheric conditions. So that's just another variable that scientists are not accustomed to, plant scientists are not accustomed to dealing with, is how do you quantify the variability of the data. And finally, frame stitchings, algorithms can introduce variation. So people are used to working with large fields and then breaking those apart. And the frame stitching, it's variable due to the tie pointing, and and that's again another level of uncertainty that is involved in drone captures. Scientists are going to single frames or extracting portions of their plots from the single frames. I talked a little bit about the precision. So I found this XKCD cartoon that I think everyone likes, XKCD. So to get an idea as to what sort of precision the scientists are looking for, it's somewhere from pointing a Waldo on a page to, hey, check out the specific grain of sand. So plant science is going to is moving towards tracking individual plants in a plot and how that plant does. So that means that you fly a drone, they want to know what plant is in that specific spot down to the centimeter, and so that they can identify the genetic traits in that plant and and that's the type of detail that is necessary, I think, for drones to succeed in this space. So you can get that with bringing a plant to the machine. You can do that with the mobile gantry that you saw before, where you can get that down to that centimeter precision. With drone, that's a little bit more of a challenge. And so this is the end. Are there any questions on what I have talked about? Yes.
Do you take anything from the considerable work being done?
Does the considerable work being done now in space, agricultural measurements, satellite agricultural measurements, either impact or get used in how you're working with the drone data and pipeline?
No, we don't at the moment. It's not totally different, but the science behind each of those aspects is pretty different. So space is pretty low resolution from a plant science point of view. So plant scientists want to know if a leaf has been cut. You're not going to detect that from a satellite. It is just a different scale. I think, not to say that there aren't pieces that can't be taken from there, but what I'm realizing, especially here, this is my first ESIP, by the way, is that even though I've been focused on the processing aspect of the drone data, I'm seeing that there's a lot of information that needs to be, or standardization that needs to be done around this for the plant scientists to feel comfortable using it and to get the results that they want. Sometimes it's all right that after a hail event and you want to see whether your corn has been stripped. I mean, that low resolution is great. You can just you can take your before and after pictures, get a coverage of the greenness of each of your plots. But if you want any more detail, you need to have the right drone. You need to know how to fly it. You need to be able to tag your data correctly. And then finally, you can get to the science that you're interested in. And so those are pretty significant barriers that we're hoping to reduce.
Thanks, Chris. On your software handling, your stuff's in GitHub, are you doing any kind of automation, continuous integration to when you tweak something in the pipeline, how it gets over to machines and things?
Yeah, so we're definitely doing that. We're using Travis CI for integration. That's so we're built off the TerraRef project, and our group is just getting underway. So we don't have their focus was to process, how do we process 200 gigabytes of data per run in this environment, and they weren't, the algorithms were hand curated, so there was a lot of testing that went on individually. So part of what we're doing is using Travis CI to automate that process so that you have the data sets beforehand, you have the accepted results, and then you can use that for continuous integration and deployment.
Thanks.
Yeah. We talked about different CI things, but we went with that as opposed to Jenkins or any other means. Right. Sorry for running over.
What is it? What do you take?
I take
USB-C or?
not USB-C, the HDMI. But there's a USB-C thing, I think.
Yeah, that looks like it will work.
Never tried, but
That's not it.
oh, let's see if it works. Oh, awesome.
Zach, is anywhere on the call right now, right? Is that- Okay, because otherwise this wouldn't work.
It was working.
What happened?
Oh, I think it just get well. I think it will work.
Again, I'll let you introduce yourself.
Sure. Hi, I'm Sudhir Shrestha. I'm with Esri. I'm a solution engineer. I'm part of the Esri's National Government Science and Civilian team, and I'm based out in the Tyson's Corner in Virginia. So I'll be today talking to actually some of the capabilities that we have in supporting drones. So it will be much more, I'll be talking about like the image, how we process the image, not going into details about like, how, we do the data collections, because if you're here, I assume you know about that. Those are the basic things, but I wanted to go a little bit in the high level to actually give you a walkthrough how we sort of like a process. Can I do my full screen? Should work. No. What was the trick? What was the trick?
Push.
Oh, okay. So,
Second icon on the top left says like slideshow or something.
It looks different. Yeah.
So-
just try those.
swap, presenter view,
No, that's
like this one?
Oh, it does look different, doesn't it?
Yeah.
Yeah, do duplicate slideshow. Try that. Oh, it's your computer.
Yeah.
Okay, there you go. That should work.
Nope.
No.
Okay, you're good.
Okay, all right, we'll see.
There we go. There we go.
Oh, awesome. Right, so I'll be talking in brief about some like how we support this workflow, and I'll be talking much more on this in the sense of the imagery management. So for us, like it is no different than getting any other Earth observation imagery, right? So we consider the same way and how we process that, and I'll talk about a little bit of pipeline of the data processing in Arcgis platform. So when we think about like in the imagery or coming from any sensor or that can be from different modalities of sensor that you're looking at, right? So we all are interested is like on the bottom side, like we have the data, how we are going to get some information products that can be used by our users, right? That's the thing that we worry about most of the time, right? And what goes in between is a lot of work that we wrangle, but like ultimate goal for our users or the policymakers or whoever is your consumers or customers, that's what they're looking for, right? They don't care about like what the formats the data comes in and how much it takes to get from that data to the information product that they can consume, right? So but the way we look at the imagery is like we start as a small project and then we scale that work to the larger data volumes, right? So basically, like the way I sort of like to categorize in like a 5 domain in our platform is like the first thing is like you'll have the raster data that's coming off the drones or any other sensors, right? And then and how you once you have that into the Arcgis platform, how you're going to manage those data sets. And once you get to there, then then the analytics starts, right? There will be the data scientists or the domain scientists who will be doing the analysis with that data sets. And in the meantime, like you will be parsing through your data sets, you're visualizing your data sets, right? And if you're like, you also would like to sort of go and drill into the particular subset of the data set you would like to look at, right? Once that looks fine, then ultimately you would like to share that to your colleagues or to the larger community, right? And that's where we'll be talking about like how we share from our domain. So the way we manage sort of imagery, we have like a data catalog system that lives in geodatabase that we call Mosaic, right? So we call it a Mosaic data set in a sense, is like, and I have one slide about the talking, but I don't want to get you into too detail. That's not the, I think that I have a talk, I'll be talking on Thursday in more detail in how we're gonna do that in imagery domain and some of the web applications. But in general, like, the way we have is like we call Mosaic data set. It's basically like a catalog system. And what it does is it basically, crawls the raster data sets, like each, like, for example, if you look at the different temporal domain of the data set you have in the raster, right? You have like several stacks and thousands and thousands of the imagery. What we do is we basically create like unique ID for each raster layers and then sync that the X, Y, and G domain, and we basically like read in the metadata coming from that data set. For example, like a NetCDF, right? So, and we support NetCDF that follows the CF convention. So we basically read the metadata off that and then basically populate it into our Mosaic data sets. So once we have that, then we're good to go how we're going to manage those data sets. From the drone perspective, like, we support like, drone, and then also create like a 2D and 3D data out of it. But like, most of our application has been used by the disaster response folks, like when they needed to do disaster response, but also on like an evaluation after disaster response recovery to look at some of the data sets, how they're going to do that, and sort of come up with the application they will use for the insurance purpose or any other purpose. But from the science perspective, like there's several applications been used in the precision agriculture domain as well. So like currently, we're starting to work with the Microsoft's like a FarmBeats project. That's where we'll be looking at in the field scale, where we'll be doing the sort of like collecting data through using multispectral sensors. And I'll be showing one example of them. I have like a Mica Sense data that I'll show in the end. So the same thing that I talked like before, like, how we sort of like work with our imagery, right? So first, like, you want to get your content into the Mosaic, and then you want to do the manage your data sets, right? Once you have that, then you would like to do the quick analysis or the visualization, and then once you have that, then that goes to the production map, or sort of like, sort of it's a user info, it's an information product that get consumed by the users. So in drone to map, like, we have the drone to map is sort of like our applications that you can use to process process your imagery, and it also gives you ability to do like, when you're doing the flying your mission, then it also gives you sort of like a look at the process in the very low resolution that gives you quick highlight of how the flight quality, the data quality is, and once you like it, then it lets you also process your data as well. But processing is not the only thing, right, that goes in, but how you're going to sort of like move that data sets into an ecosystem where you can do more than that, right? So you can do the process your single frame imagery, but also we also support like a 3D creating a 3D message in our platform. And drone to map, in what we are also working on, like looking at like some of the flight that you can look at doing, especially when you're doing the disaster recovery, they're supporting like oblique imagery as well. So we also are starting to work on the supporting this, working with oblique imagery as well. So processing, like, so there are like two, right? I mean, I don't have to preach the choir here talking about the values of what the oblique imagery, these slides are for our users who are not very, who probably we need to tell them what is the difference between like, the imagery that you're getting has a value from a native ones, and then the oblique imagery. But the idea here is like when you have the data, then we have the software that we support on that, and then idea is like move it and support to the doing the data management, right? So the workflow is like, you just create the projects, and then it's a basic like workflow, right? You can run the processing, and then the processing will be done on the level that you would like to use, right? So the idea is also like integrating with the Arcgis platform. That's where it brings into the value, right? So it's the Arcgis, drone to map is a single standalone applications, but once you process that data, you can push it to into the Arcgis enterprise, where you will be able to do all the analytics, right? And this is a part of now also, like, we have integrated that capability in the Arcgis Pro. I don't know how many are familiar with our Arcgis Pro here, maybe. Oh, wow, I'm impressed. So we have added those capabilities into Arcgis Pro as well, actually, where you can get those data, and then once it's in the Arcgis Pro, you can do all sorts of analysis that you would like to do, right? So on the desktop as well as on the server side. So two things, right? So we also have like a different servers like that manages the images, but you can also actually push that directly to Arcgis Online or the portal. So the difference, I would like to clarify here, there's a difference between Arcgis Online and a portal, right? So the Arcgis Online is like is Esri's like a SaaS platform, right? Where you have the software and analytics available to you, but a lot of the consumers, where they don't want to use that, but they want to also just would like to have their own platform. So it's basically like a portal is like your own controlled version of the Arcgis Online, right? And that basically gives you access to control all your software and how you work with your data, right? And then like you are able to share that 2D products as, again, that you can create the base map, right? You can that actually bring in those base map into your Arcgis, into the web interface, as well as into the Pro as well, right? And the whole thing about like sharing the product, right? Because like these images are pretty huge, and then once you work with how you're going to share that across, right? And it's pretty easy to share those into the Arcgis platform as well, right? You can create this we support 3D scene layers as well in that. Another cool is like thing is also like we support like a dynamic mosaic using the mosaic data sets, right? Once you create the mosaic, then you basically you do not have to stitch those images together to look at it, right? It does all those mosaicing on the fly for you when you're looking through the images, right? You have like several pieces of the images that you have taken at the time, but like once it is in the mosaic data sets, it will sort of like do the mosaicing on the fly for you. All right, cool. So I'll rush. So this is quick to show like some of the LiDAR data as well. And there are several tools that we have available, and I'll be happy to talk a little bit more in detail, but what I would like to do actually show pretty quickly this one. So we talked about like the imagery workflow, right? So once you have that data, once you push it to the image server, then you have ability to do that, right? So once push that service as an image service, this gives you ability to actually look at that. So this is basically it's a MicroSense red edge camera that we have, and this is something we pushed as an image service, right? So just to give you a quick on what it looks like, right? So this is like a short through the image service. This is gone through the Arcgis REST API, so you can do the REST API call as well, right? But if you would like to take a look at the visualization as well, what you can do is like for example, a lot of the people here, I mean the other users, like you have several indices or several analytics that you have, right? And they may or may not know how to calculate those algorithms. So what we allow is you basically can create some of the Python function API that you can attach to the mosaic data set. And once you serve that as an image service, those templates are available for others to use, right? So for example, someone wants to do the band, this natural color, this will basically like calculate on the fly for you, right? So this is sort of like, and you can consume this services directly into your Arcgis API as well. So basically this is just, if you look at the properties, you can consume those sorry. So you can see this is the link for your data, right? So it's a link for the data from the REST API. So what I'm here to say, like, once you have that imagery into the platform, then you're able to share, and then you have all the abilities to do the analytics that you need, that you would like to do using the Arcgis Pro that brings in, right? One last slide I'll talk, and then I'll shut up. So other thing is actually, how you integrate the data with that, right? Once you have that imagery, that you will be able to actually integrate, with some of our other analytics that you can use. We have the Arbridge that we talked about. One of my colleague yesterday, he talked about in some of those, but in some of the integration, the AI and machine learning tools as well, right? But also, like, we have a hosted Python notebook, and very quickly, I will not go through it, but will give you sort of like a quick on this one. So this is the Venus data, the Israeli satellite data, but the idea is, like, once we have that data available into the REST API, you can use and consume those here, and actually, use our module as well as the other that you can get off the Anaconda as well, right? You can bring in the scikit-learn and all the others, right? So this sort of like lets you expand the work that you're doing in that domain as well. So it's not only about the managing the imagery in like a standalone version, but sort of like a platform where you can scale your work. And I'll be happy to talk in more details. All right, I tried to cover a whole lot in short amount of time. Thanks, Jay. If there's any questions, I'll be happy to take it.
About 5 minutes to lunch, and I still want John to talk, and I definitely want to give us time for the pitches before we break into groups. So,
I promise to be brief. That helps.
yeah. 10 minutes? Is there a 5 minutes left?
I guess any questions?
Yes. You good with that? Okay.
If you can get it, so
I don't know where we left the connections.
Yes.
And I'll go ahead and start talking while you're doing that.
Well, that sounds great. And then we'll do the pitches for the different breakout groups after lunch.
So my name is John.
Sorry, it's all the way over there.
my name is John.
Everyone.
Okay, my name is John Graybeal, and I know many of you. It's nice to see a few faces that I've known remotely for a long time and worked with. I'm working at Stanford University as the manager of the CEDAR project, which is a editor project that I'll be talking about, and the BioPortal project, which many of you have heard of for managing vocabularies and ontologies, and is used by the CEDAR project for its ontologies. So excellent, thank you. So this talk should have been retitled Metadata for Drones because it is a bit customized for that. Boy, we're just tussling along. I think maybe it stopped. We'll see. And I've done a lot of work in this area of earth science for a long time before I started working in the biomedical community. So a lot of this is quite familiar to me. So CEDAR is a metadata management solution that is sort of a little orthogonal to a lot of these previous conversations, and is meant to be maybe a solution to some of the issues that have been identified. CEDAR lets you, like Google Docs, Google Forms, SurveyMonkey, lets you create the forms to collect your metadata, but then also link those forms in a very precise way to the terminologies that are in BioPortal, so that you can describe what the fields are about and constrain what the answers are to the fields. And this is all to aid the interoperability problem that we've talked about, where people are using different words for different things. And it also lets people access other work that's been documented in CEDAR. So it can represent most models. It has an Uber model, if you like. It's representing things internally in JSON. The forms are JSON schema. The metadata itself is JSON LD, which is designed to be convertible to RDF for those who are working in that semantic framework. And it is meant to make all of these things rather simple so that people can just come in and start working with it. And one of the ways in which we may talk a little bit later about using Cedar in this context, and that we have used it a little bit already for this purpose, is for modeling metadata, such as drone metadata. And I'll get to an example of that very quickly here. One of the things about Cedar is it's built as in a very component-oriented way with a lot of good APIs. So you can actually deploy it if Cedar is this box on the right side here. In this case, it's for this particular user, it's just handling metadata generation, and that's it. Users can come in, fill out the form, they're done. That's all that it's doing. In other cases, where it's a bigger box on the left side, it's handling the design of the template and the metadata, and then the submission of that metadata, including data to an external repository. It can be composed in different ways for different problem sets. We've done an example collection of metadata for marine science. This was an example from David Clegg, where I didn't do the whole thing, but this top half basically created all the necessary collections, so on. And then a year ago now, was it? A year and a half ago at RDA, we sort of talked about this minimum presentation of metadata, minimum information framework for the drones. And so basically in half hour overnight, with a little bit of help, we just got an example of this represented in Cedar. I'm sorry, it didn't come out quite big enough for you all to see in the back, but Google Doc type presentation layer. And is Sarah in the audience? Is she still with us? Or? Okay, so I believe everyone has access to this, and you can log into Cedar anytime, get an account anytime. It's at cedar.metadatacenter.org. And then you should be able to search for drone and find this folder, if I'm not mistaken, which has all the different elements for the different parts of the metadata model that we saw previously. If you actually open up the overall template, this is the top of it that shows, first of all, the project information, and then it goes on from there. And then you see the details when you actually try and fill out the metadata. That is presented back, sorry, that's presented back to you as a form that can be easily filled out. And one of the advantages of doing Cedar for some of this is it's fairly tractable to move things around and reorganize the metadata that you'd like to collect. So I'm not going to do a demonstration at this moment because of time reasons. I'm imagining this PDF will end up somewhere, and I'll just let you know that there's a second half to it that actually describes BioPortal in a little bit of detail. A key point is that although some of you may think of BioPortal in the biomedical domain where it was first established, anyone can actually submit any kind of ontology to it. We have a number of earth science ontologies, including Suite and others already there. And so to the extent we create additional vocabularies for the drone meeting today, we could get those into BioPortal, and they would be both visible to the community and usable for something like Cedar. And so there are additional slides about that here that you all can look at your leisure. I think I'll stop there.
Thank you very much. You're going so quickly. Yeah, so that's a nice hint of some of the topics we'll be thinking about after. I wish we had time to introduce them all, but in brief, if anybody knows what OpenAPI is, building RESTful APIs that can link to ontologies for some of these bits. For instance, you want to interact with Esri's tools, or you want to take your Pi that's on your drone, capture your data, and as soon as it hits the internet, push that data up to your server, and it's all already semantified. Modeling, so part of that is we need an ontology that represents a drone. There isn't one. Chuck has started working on that. So there's gonna be a group that's thinking about that and some other holes in the ontologies that we need. And then I have ideas for how we could use Cedar to build community schema in the sense of, so my example use case is atmospheric scientists are wanting to submit drone data to atmospheric models. Atmospheric models have data schemas, NetCDF mostly, but we have to link those two things. And so let's create a community schema for monitoring CO2, atmospheric pressure, humidity with sensor X that is then compatible with WRF. Think about any other application. But so we'll pitch a little bit more and give you a bit more detail, but after lunch, go and enjoy lunch.
I think there's two.
You all just want to stay? I'm hungry. Yeah, it's lunchtime now.
So did you create any new issues?
I don't know whose this was.
That's right, you brought that up earlier. Did you create that? Perfect.
Do we have a second reusable?
Yeah, does anybody else want to? I've got some notes.
Margaret.
Plus I love to talk. Okay, so we looked at the GoFair facets and decided that the first two were pretty easy and you had those covered, but the third one is domain relevant community standards. And was pretty much, there's nothing in this list, that's not a surprise. And we also, one of our conclusions is that reuse pretty much always has context, and that's how somebody is going to want to use it. So we kind of dived into thinking about how you would evaluate fitness for purpose, and that it almost always requires a human. So we did started to design a few checks that actually might look for particular aspects of things that a human would look for, like we'll put them into issues, but they're not there yet. There are things like, are there references for taxa? Are there vocabulary requirements that are met? Has this data set been used before? Has it been cited? Does there a scientific peer review as in a data paper? Some forms of user community review or other kinds of annotations or maturity checks. Annotations and citations, yeah, I think we got those. Anyway, that was very vague, but we have a collection of notes which they tell me I should just dump into one issue and say, here, reuse this.
We do have a few people online. I'm sorry about the challenges with the microphone.